Alright, over the past couple of weeks we've been doing nothing but solving systems of equations. We've done it a couple of different ways. We've done it by using substitution, which means by plugging values of x, y, and z in to see if they work. And the second method that we've been doing is by graphing, where we graph both equations and then we see where they intersect. So what we're going to do today is kind of fill out this chart, and it's just a little bit of a summarization of what we've been doing and what we've learned. So at the very top it says when solving systems by graphing, there's three different things that can occur. We can get two graphs that look like this, two graphs that look like this, or two graphs that look like this. Notice it's a dotted line. That would be the second graph. So it says, what types of lines are these? Well, the first one, these are our lines that don't touch. These are our parallel lines. And when they are parallel, it says, what type of solutions do we get? Or actually, how many solutions do we get? Well, in this case, we said that the solution is where they intersect. So if they're parallel, they don't intersect, so we really only get one solution. So it's not plural. Okay. The second type of lines are these type. These are not perpendicular. You guys love to say that these are perpendicular, but they are not. Remember, perpendicular lines make 90 degrees. These are just plain and simple. These are intersecting lines. And when two lines intersect, they always intersect at one point. So it would be, oh, I'm sorry. I said no solution and then wrote 1. Parallel lines have no solution. Sorry. And intersecting lines have one solution, and it's represented by the intersection. Okay. The last type of lines, we called these overlapping or coinciding. You need to be able to recognize both, so I'm going to put them both in here, coinciding or overlapping. And this occurs when two equations end up being the exact same line. And this is what we said created an infinite number of solutions. Or every point on the line is a solution, because this is actually one line sitting directly on top of the other line. Okay? So some things to think about down here, some other vocabulary. It says sometimes the blank blank is used to describe the solution to such a system. Sometimes they will call this an empty set. Okay? Or they will use this symbol, which you guys have seen before. So no solution, sometimes called an empty set, or sometimes looks like this. Now, what we need to learn today is that we do not have to graph a system of equations to figure out if they're parallel, intersecting, or coinciding. So let's look at parallel first. This is something that we have talked about before. We say that parallel lines have always had the same slope. So I'm going to go back and take a peek real quickly at our other set of notes that we already completed. If you remember this problem right here, when we changed this equation, okay, and we worked it all the way through, we came down here and we got a b value of 1 and an m of 1/3. On this equation, the first one, when we changed it around, we got a b value of -2 and an m value of 1/3. What you needed to recognize is that the slopes were the same. This one was 1/3, this one was 1/3. So even without graphing it, we should have recognized that these were going to be parallel lines. So again, if the slopes are the same, 1/3, 1/3, but the y-intercepts are different, that means that the lines are going to be parallel, no solution. Okay, or again, we said that that could be empty set. So if you want to write that up here at the top, you can. I put same slope. You may want to also write different y-intercept. Okay, that may be the other telltale sign for you. So if they have the same slope but a different y-intercept, they're going to be parallel. Okay. So now let's look at our other special case. These were coinciding. What we need to write up here is that it's the same exact equation. That means the slope is the same and the y-intercept is the same. So again, let's go back and look at the old set of notes. Let me fold it so we can see just that problem. If we look just at this problem, notice it's the same thing. Here, when we solved the equation and we simplified, we got a b value of -1 and an m value of 2x. For this equation, when we solved it, we got y equals -1 for our b value and 2x for our m value. Notice they are the exact same. So the b value is -1, b value -1, slope is 2, slope is 2. They are the exact same equation. So when I went to graph, I actually only got one line, even though it's two directly on top of each other. So they are coinciding or overlapping. And again, they have infinite solutions. Infinite solutions. Okay. So your task on this sheet is going to be down here at the bottom. It says on graph paper or on a calculator, solve each system graphically. Then describe the type of lines, whether they are parallel, intersecting, or coinciding. Again, remember coinciding just means overlapping. And then you're going to tell me the type of solutions. Is there one solution, no solution, or infinite solutions? So remember, you've got to compare the slopes and the y-intercepts. See if the slopes are the same, if the equations are the same, or if they're different. Okay? If they are completely different, and again, this would tell you up here, all you have to look for intersecting lines is different slopes. If they have different slopes, then you automatically know that they're going to be intersecting lines. So your job is to complete 11 through 16 at the bottom. And if you need graph paper, since I didn't actually give you any, to complete these or to solve them graphically, then come up and ask for some.